Hi, and welcome to Centralized and Secured Secrets Management Strategy with Entrust. My name is Graham McCord. I'm a Senior Manager of Strategic Alliances, and I have the privilege of managing our partnership with HashiCorp, as well as introducing the speakers for today's session. Juan Asenio is Director of Product Solutions and Partner Marketing, and Charlie Schell is Product Manager for Entrust PKI team with a focus on our PKI ecosystem. Both bring a number of years of experience and expertise to the discussion, and so they are the subject matter experts who will share their perspective with you regarding the best way to secure your secrets management environment. But first, for those who are not familiar with Entrust, let me provide a brief overview of who we are and what we bring to this discussion. For over 50 years, Entrust has brought trusted identity and secure transaction technologies to market. Our solutions range from the physical world of financial cards, passports, and ID cards to the digital realm of authentication, certificates, and secure communications. With more than 2,500 Entrust colleagues around the world and a network of strong global partners like HashiCorp, our company serves customers in 150 countries worldwide. We are trusted by some of the largest governments, financial institutions, and corporations to handle their most sensitive transactions. While Entrust offers a complete breadth of digital security and credential issuance solutions, today's discussion will be focused on our industry-leading hardware security module and public key infrastructure offerings underpinned by our deep expertise in cryptography. The zero trust model not only requires centralization of secrets in solutions like HashiCorp Vault, tied to an HSM-based root of trust, but also the controlled consumption of those secrets through DevOps automation. In partnership with HashiCorp, we enable customers to ensure the security of their secrets management deployments. And with that, over to Juan.
Well, thank you, Graham, for the kind introduction. The agenda that we have for you is to first define what secret sprawl is within the context of the zero trust environment that Graham just introduced, and discuss the challenges that secret sprawl represents to organizations. We'll examine why centralized key management is critically important, and we'll then take a look at the particular challenges that cloud, DevOps, and regulations represent. And we'll then introduce the concept of the root of trust and explain why it is required for high assurance security. So with that, let's get started with the relationship between zero trust and secret sprawl. And to do that, let's take a closer look at today's computing environment. Today's computing environment is highly distributed. It is comprised of on-prem, cloud, multi-cloud, and hybrid type of deployments in a very dispersed layout, and applications, each holding their own credentials and secrets in their own different silos with varying degrees of lifecycle management and protection policies. Then on top of that, we have increasing use of the zero trust policies where no one and nothing is trusted by default, and where everything is repeatedly authenticated to validate identities and to validate integrity. And what's happening? This creates an environment where we have inconsistent accountability. In some cases, organizations don't know how many critical secrets and credentials they have or where they're maintained. And not having a centralized secrets management process really creates risk and audit challenges. So what's the problem with this picture that we just described? The problem is that the number of organizational secrets keeps growing. And it's not only because of the distributed system, but also because of the zero trust approach, validate everyone and everything at every step of the way, at every step of the process. And this is all well and good. Don't get me wrong. This is good security practice. But it's actually creating what is commonly called secret sprawl. I'm sure we can all relate to this on a personal and individual level. We all have increasing number of usernames and PINs and passwords that we all need to remember, And we all use different types of tools to help us with that. And when you look at this at an organizational level, the problem becomes much bigger and harder to solve. Now, before we move any further, let's make sure that we're all on the same page when we talk about secrets. What are they? What are organizational secrets? Organizational secrets can be tokens or representative values. They can be passwords. They can be certificates. They can be keys such as symmetric keys or API keys, or any other type of credential that is used across this diverse computing environment that we described. And they're used to gain access to different applications and to also protect the information that those applications are processing within that digital environment. Now that we know how today's computing environment is creating this demand for secrets, let's examine the challenges that this sprawl is causing organizations. There are essentially three challenges. First is the growing number of tokens and passwords and pins and certificates and keys, which means that organizations don't really know what they have. And then we have the zero trust environment. That means that there's more validation of these. And this means that there are more credentials and more secrets to keep secure. And the more secrets you have, the harder they get to be managed. This lack of visibility then leads to the second challenge, which is lack of control and auditability over these secrets. And this leads to the third challenge, which is unfortunately where the real damage can occur, and that is the inability to properly protect secrets and contain potential damage due to compromise. Now, I mentioned earlier the challenge of maintaining consistency in security policies. So let's now examine how centralized key management helps with this. So what are we really protecting and why? We need to ask ourselves, what are the underpinning organizational requirements that are getting us to this point? And from a cybersecurity perspective, we have secrets in the first place to protect infrastructure, to protect applications, and ultimately to protect data that is processed by these applications, which is a very valuable enterprise resource. So the requirement really includes data privacy, data integrity, data control, compliance, and we can also add sovereignty of data depending on where data is stored and processed. And the risk of attacks that result from the sheer volume of applications and data and the workloads that we now use. It's also the fact that everything is connected, and the growth in the number of vectors or conduits that can be used to perpetrate different types of attacks. They're all on the rise. So we have to keep that in mind when we assess the security of systems. And this makes data confidentiality and privacy a major concern. There's also data integrity, ensuring that applications and data are not altered or changed, because that can change the outcome of an analytical workflow. And then add to that the fact that data is now often subject to laws within different nations or states where it is collected and processed. And we also have to think about the data sovereignty and the regulatory environment, which become significant aspects to also be concerned about. So we can see why then we need a foundation to deal with these types of requirements. And that is where the need for a root of trust comes into play. Let's examine the first three of these requirements. That is data privacy, data integrity, and control over data, which are essential for ensuring that we meet the other requirements. To protect data privacy, we use encryption. To protect data integrity, we use signatures. And to control processes, we use credentials to ensure that only legitimate people and legitimate applications have access to each other. And all of these use some form of secret, some form of credential. So what is common across all of this, that one common denominator across all of these processes is cryptography. Without cryptography and cryptographic keys, we cannot do any of these types of processes. We cannot guarantee security of data and the access to different types of applications. So therefore, the common denominator, which are these secrets that we define as being all these components that allow us to gain access to different applications, they form that root of trust. And we'll get to that specific in a minute. But before we do that, let's examine the solution to the overall secret sprawl problem. And then we'll take a look at how we can enhance that with an extra layer of security. So the solution to secret sprawl includes really three aspects. The first level is centralization. We need to move from secrets that live everywhere in those different silos that I described earlier to secrets that live in a single place where it's tightly controlled access and tightly audited. The second level is the establishment of fine-grained access controls restricting what secrets different individuals have access to on a need-to-know basis. In this sense, we have a good answer then around, if there is a breach, we have an audit log of who had access, when did they have access, and so forth. And we can change it we can put all that in a central place and distribute that into the infrastructure and simplify the life cycle around that credential management perspective. And then finally, there is automation and distribution of credentials, particularly certificates. And Charlie is actually going to talk about this shortly in more detail. Now, looking back at those items that I described, centralization, the first one, is where HashiCorp Vault actually comes into the picture. Vault centrally manages and protects organizational critical credentials and confidential assets. It enables the use of diverse infrastructures, secures, stores, and controls secrets, and renews and even revokes access to applications and facilitates that audit that I mentioned earlier. And note that the secrets stored in Vault are sealed or encrypted. And to unseal the Vault then requires an encryption and a decryption process, which is where that additional layer of security comes into the equation. So this brings us then back to the point that we need to establish that root of trust. Without having this step, you really don't solve the problem. You're just introducing another secret to control access to the Vault. How do you manage that secret? The solution here is to segregate this one particular key, the master key, from the rest of the system. Then you all those secrets that you have kept in the Vault, encrypted using that master key to unseal the Vault. You use then another key, an encryption key, to protect that master key. And that is where that additional layer of security that you see here on the right side of the screen comes into the equation with the application and the integration of an Entrust Enshield hardware security module, or an HSM. Now let's look at why migration to the cloud with increased use of DevOps and continuous integration and continuous development approaches are creating a need for more secrets. And I'm going to turn it over now to Charlie to explain this in further detail. Charlie?
Thanks, Juan. What I want to talk about a little bit is is automation and how that complements the story that Juan was just discussing. If you think about today's environments, they're complex. They often are hybrid multi-cloud environments, so that not only is it do you have lots of servers and endpoints, but you also have lots of locations where those exist. So the number of secrets is expanding, and maybe more importantly, the frequency that those secrets are turning over is expanding. It's become really to the point that without automation, it's very, very difficult to be able to keep everything up to date. And without automation, it's all too easy to forget to distribute something to some critical endpoint or to do it incorrectly. So we'll talk about these topics here. And I want to go ahead and use PKI as an example. We'll drill into that. Many of the secrets that Juan has been discussing are really about asymmetric keys that, of course, are carried and distributed through certificates. So this is a picture of showing sort of how certificate authorities over on the right-hand side fit into the picture. So if you think about, certificate authorities are used to generate certificates and sign them, and then they are, that can then be stored in Vault. But the thing which is important is that that same root of trust that Juan was discussing that is anchoring Vault can also be used to anchor the CAs. And so if I complete the picture here, then we've got really Vault as a central storage point. And over on the left-hand side, it is handling certificate requests from various different orchestrators and deploying those certificates to various different endpoint infrastructures, whether these are Kubernetes components or your own applications or anything in between. And that's all part of an automated process. But over on the right-hand side is where we have a lot of back-end infrastructure to make all this happen. We have the CAs that are signing the certificates and distribute them through Vault. Entrust has a Vault plugin that's part of our CA Gateway product, which is used to be able to do that. So it's an open source component that you can use. We support, and it allows us to take certificates generated from any number of CAs and be able to tuck them into a Vault infrastructure and therefore support that automation. And again, all of this then is anchored by that common root of trust down at the bottom, whether that is a cloud or a on-prem type of component. There are obviously multiple different ways to do that. As Entrust has, our InShield product line has both the cloud and on-prem versions of the system. I want to talk a little bit about the certificate hub component at the top. That you have in any kind of system, you need to be able to have a total view of all the certificates that you have within your system. You need to be able to do issuance of those that sometimes take manual actions, generate reports. And so we offer a component called Certificate Hub, which is also part of this picture, that can give you a single point of view of all the certificates in your world, and also be able to push those through an automated fashion into the Vault infrastructure for then subsequent deployment to various different workloads. I think I'll turn it back over to you, Juan.
Well, thank you, Charlie. So this is an excellent segue that brings us back to the root of trust. We need to protect underpinning cryptographic keys used to unseal the vault. And we also need to manage these keys and maintain control over their process throughout their life cycle, given that they truly are the keys to the kingdom. To do that, we need to institute best practices, including the use of hardware security modules or HSMs, really safeguard and manage these critical keys. So why do we need a root of trust? Aggregating these secrets means that we need to pay special attention to how we protect the master keys that seal that vault. First, we leverage the security of a certified hardware, completely segregate the encryption keys that protect that master key that is used to seal the vault. Second, we generate high-quality keys using hardware-based random number generation, and subsequently manage these keys lifecycle within the protected hardware environment of the HSM. And third and last, we add a layer of security over policy enforcement and access control that is certified and facilitates regulatory compliance. So I'm not entirely sure how familiar many of our viewers might be with hardware security modules. So allow me to take just a few minutes to explain what they are and why their use is critical as we manage secrets that control access to infrastructures and to applications and workloads. HSMs are specialized appliances that operate independent of applications and typically attached to the network to keep watch over cryptographic keys. And they also process and do cryptographic processes on behalf of those applications. Applications can live on premises or they can live in the cloud. And as a matter of fact, as Charlie mentioned earlier, the HSM itself can be an on-prem appliance, or it can also be an as-a-service option, where the HSM is actually in the cloud as well. The point is that critical keys are isolated from the host environment and are always protected inside the device. So in this way, the security domain is completely segregated from the rest of the system. They also implement and enforce defined security policies, and access to the security domain is enforced with dual controls. which require more than one individual to be able to put in or change a process. And that's very important in order to ensure the security of a corporate system. HSMs are also typically certified to the Federal Information Processing Standard, or FIPS, and also to the Common Criteria Standard, which are the two most widely recognized standards for cryptographic robustness, and are normally integrated into applications to really operationalize trust and ensure that security can be delivered automatically and at scale. And speaking about compliance, the integration of the Enshield HSMs brings a certified FIPS 140-2 Level 3 and also Common Criteria EAL4 Plus hardware platform. Now, HSMs used to be deployed mostly by banks and financial institutions, but what we're seeing now is that their use has really grown across all sorts of applications. The latest Ponemon Institute Global Encryption Trend Study shows a cross-section of the top 10 use cases or applications where HSMs are increasingly being used today to ensure that keys and data that these applications are processing remains secure. And not surprisingly, public clouds is number 3. And application level encryption is at the very top of the list. And you can see the rest of the different applications where the use of HSMs is just steadily increasing across the industry. And as we wrap this session, let me quickly highlight some trends that I believe are very important to recognize as we deal with the secret sprawl problem. The recently published Ponemon Institute 2021 Global Encryption Study can give us some clues into the need for secrets management. If we look just at the trends in encryption strategy over the past 15 years, we see how this has increased significantly and continuously. This means that for this practice alone, that is the practice of encrypting data, more and more encryption keys are being used. And add to that all the applications that we need to access for ensuring the security of different types of data, all the different tokens, passwords, PINs, and other credentials, and the volume of secrets that are used by organizations is growing dramatically. And then, of course, we add the zero trust approach, and this just becomes a huge endeavor to be able to keep up with the management of all these types of secrets. There's also the proliferation of certificates, and also the 2020 Global PKI and IoT Trend Study that was also published by the Ponemon Institute showed a 43% increase on their use. And the demand between 2019 and 2020 was a dramatic increase. The very certificates that we use to authenticate people and to authenticate an increasing number of things that are now connected to each other. Another study from the MITRE Corporation that also predicts that the market for digital certificates will exceed 100 million by next year. And this is all to ensure greater trust across different platforms. So I'm going to turn it back to Charlie to cover regulations, because really no security presentation is complete with a look at the regulatory environment that we also need to ensure that we address and comply to. Charlie?
Thanks, Juan. Yes, I mean, if you think about the drivers, why it's important to protect your data, Juan's talked a lot about that. And one of the main drivers is really regulatory compliance. This is a great picture because it really gives sort of a heat map, if you will, here of where regulations are strong. And there are lots of them, right? I mean, GDPR, everybody knows, HIPAA, the California Consumer Protection Act. In the payments industry, you've got PCI Digital Security Standard, you've got the Payment Service Directive 2. All these things have a lot of commonality. They all talk about the fact that you need to take appropriate levels of control to protect data. Many of them really go so far as to say that that dual control of keys is required to assure that no one single person a rogue employer, if you will, can go in and do harm. And so it's important as we look at this that we need to be able to create solutions that meet these standards, that protect the data, and more really that is really as things become harder to protect, as essentially attacks become more and more sophisticated. Really, it's coming down to it's required that we use hardware encryption through an HSM to be able to meet these standards. Back to you, Juan.
Okay, thank you, Charlie. So as we wrap things up, what are the takeaways from this? Zero Trust is all about authenticating everyone and everything, and doing so repeatedly. The practice really strengthens security, but it also increases the use of secrets and other types of access credentials. And as more enterprise applications use secret access credentials and these increasingly use their own types of repositories, this creates those silos that we talked about earlier, where it becomes harder to manage, and organizational secret policies become inconsistent. And that's where HashiCorp Vault comes into the picture, by providing that centralized repository for organizational secrets. And then together with Entrust and Shield HSMs, provide that additional layer of security that is necessary to protect those keys to the kingdom. So with that, I thank you for your attention, and we invite you to send your questions through the chat feature, and we will be very happy to address all of your concerns and questions at this point. And again, thank you for your attention.
Great. I think that we've got some questions, Juan. Some of them are really for you if you want to go ahead and take them first.
Okay, let me take first one here. Can you comment on the reasons why an enterprise would use an HSM service versus an on-premises hardware platform? And so the reasons for that, I mean, we talked about the fact that DevOps and the whole environment right now is to more and more use cloud applications, use distributed systems. So the question really becomes, why not a cloud HSM as well? And indeed, that is something that, as we said during the presentation, we offer, and we are encouraging customers to also, take advantage of that. The use of a cloud HSM doesn't mean that you are accepting any less in terms of robustness, because you are essentially using the same hardware platform that you would be using if you had it on premises. It's just that you're using it as a service. And by doing that, you are then taking advantage of the fact that you can pay as you go. You pay for what you use, and you also leave a lot of the administrative aspects of it to the cloud, to the provider, to us as the provider of the HSM service. So you reduce that upfront cost. You turn it your capital expenditures, you turn them into operational expenditures, and you can use what you need and scale up or scale down depending on your requirements. So again, you're not losing anything by doing that, and we encourage customers to take advantage of that, as we are all taking advantage of cloud services for that very reason. Let's see, another question. Advantages and disadvantages of using the same root of trust for Vault and PKI. So I think, Charlie, you mentioned the use of the HSM in support of the PKI, in support of the certificate authority, and the HSM. And again, whether it's a cloud-based HSM or whether it's an on-premise HSM, you can use it across multiple applications. And essentially there is no disadvantage of doing that. You're essentially maximizing your capability of the HSM, whether you are protecting the master keys that you're protecting the vault, whether you are generating keys for a signing application, whether you are generating keys for a PKI, or protecting keys for all sorts of other applications. In fact, HSMs are used across the board. You saw one of the slides that we had that highlight how HSMs have gone from just being in the banking sector, where now they're used across the board in many, many applications to do just that, generate keys and also protect keys on behalf of those applications that are using cryptography. You want to add anything to that, Charlie?
No, I think you covered it pretty well. I mean, I guess in a service model, I mean, it really doesn't matter if it's an on-premises HSM. Then of course it allows you to maximize your use of the hardware that you purchased.
Okay. Okay, and we have another question here that it's a bit detailed here, so I'm going to answer it, and if I can, you're welcome to send us a direct email. You saw our contact information, and we can get right to the bottom of it that way. But the question is, using Entrust, you can do both seal wrapping and auto seal of the HashiCorp vault, where the HSM vault master key is stored on the Enshield. The Enshield Connect. The Enshield Connect is actually the unit, the hardware platform. Is it going to be a soft card or an OCS card that is used? I believe you can do both, but I will get that particular detail for you. And if you send me an email, I can get back to you with the specific around that. And let's see. We got another one here. Why is secrets management so important in DevOps? So we talked about DevOps and also the zero trust approach. And when we're talking about DevOps, we're talking about this continuous iteration and continuous development and improvement environment where it's become really the new way of developing code and software. And in doing so, we have more and more of those iterations where the developers are accessing different applications. So for each one of these applications, we have more credentials that can be any of those that we described during the presentation. And also we have on top of that the zero trust environment where we are constantly validating the identity and the integrity of those peoples and things, because many times in this interconnected environment and the Internet of Things, many times it's not just people, it's actually different applications that are talking to each other and needing to authenticate each other. So we have this growing, or perhaps exponentially growing environment where we have so many credentials that we need to maintain and we need to manage in a centralized environment where we know where they are, we know how to manage them throughout their life cycle. And then we have that concentration where we need to then ensure that that aggregation is protected, and that's where the HSM then comes into play to add that additional level of security to that and ensure that the keys that are protecting those secrets are protected to the highest possible standard.
Yeah, we see the same kind of thing in PKI. I mean, as you're saying, the number of secrets is expanding almost exponentially. That's true of certificates too, and so yeah, I mean it's both that this expansion is both just because, of course, sort of the world's expanding, but it's also just that the time frame or the life of these secrets is really becoming much shorter. In a DevOps environment, you essentially create a lot of these things dynamically as part of your deployment. They live as long as the container lives. When the container dies, the secret's revoked. So it's becomes
very important that you set all this stuff up automatically, so that, because you can't keep up with it in terms of any kind of a manual process. It's really just kind of gone by the wayside here.
Okay. Yeah, we have another question here on licensing. How are Entrust HSMs licensed? The Entrust HSMs, and I'm not sure we went into that level of detail in the presentation with regards to the different models, but in the hardware models, we have the Connect, which we made reference earlier, which is the network connected HSM, and that one is the same one that would be on an as-a-service application. It's just that instead of living in your data center, it will live in a cloud service data center. And that one is, if you have it on-prem, it's licensed for the number of applications. It comes with 3 licenses, but it can scale up to, I think, close to 100 different applications. And then for the as-a-service, we have different plans available. So again, I would suggest that you contact myself. I can put you in contact with the right people to answer that specific question with regards to the licensing models for that in an as-a-service environment. And then I wanted to mention that there is also a card HSM, which is what we call the Enshield Solo, which is a PCIe card that actually is embedded into a server, and that provides it's a one-to-one type of environment where it's dedicated to the application running in there.
I think you also have a developer program, don't you, Juan?
Yes, we do. We have another device that it's called the Enshield Edge. So yeah, thank you for reminding me of that, which is it has the same functionality as the rest of the units. It's also certified, and it is used for low volume applications. But from a security perspective, it's the same environment, the same what we call the security world key management architecture, which is actually an umbrella application across all the HSMs that distributes the keys and ensures that you can have a central management of the HSMs, no matter which type they are. And those in particular are used for low volume type applications for key generation, and many times related to CA types of applications. Let's see, I just saw this blip here. Entropy is important when generating keys. Can you comment about the aspects compared to using software? Very good question. That is essentially one of the main reasons why we would want to use a hardware, an HSM as the root of trust. If you are generating keys for any types of applications, you want those keys to be quality keys. And what defines a quality key is the level of entropy, the randomness of the initial seed that is used to generate the key. And that also can be something that can work against you, and I'll explain why. And that's because a lot of people say, well, I have keys, I store them in software, it's going to be very hard to find them. And the answer is no, it's not very hard to find because of the randomness of those keys. One can do, and there's been multiple studies done around this, where you analyze a database or a software application for where keys are, and you can readily tell where they are because of the randomness of the data in memory. And you can pinpoint that their keys are over here or there, depending on that level of randomness. And that then allows an attacker to be able to go after those keys, which is what hackers do. They know that most information is encrypted, but they also know that a lot of people put the key under the doormat, so to speak, and it's just a matter of finding the key. So it's just like trying to get into your house. They're not going to break the glass. They're just going to look for the key hidden somewhere, perhaps under your doormat. And unfortunately, we see all too often we see that where keys are just left in software and they're found, and then the attacker is able to perpetrate the attack using those keys. So very good question. Thank you.
So it sounds like you should either use crappy keys or you should store them in hardware.
Well, no, I mean, you should use good keys because that's what an HSM does. It gives you good keys, and it gives you also a good place to store them away from the attackers.
Yeah.
So let's see, I have another question here. How do HSMs help regulatory compliance? So Charlie mentioned, regulations towards the end of the presentation, and we also mentioned the fact that HSMs are certified. They're certified to FIPS, the Federal Information Processing Standard, also the common criteria. So for FIPS, we're level 3. For common criteria, we're evaluation assurance level 4+. And what this means is that these are the two most widely recognized standards for cryptographic robustness, and that ensures that keys are generated in a quality way with random number generation, and also that the mechanisms that protect those keys are strong. And some of those mechanisms, and Charlie mentioned some of these, are having dual controls. No single individual or no single entity is able to single-handedly tamper with an HSM and be able to change key use policies. The HSMs are also tamper resistant, so any attempt to do any physical penetration is also registered. The device really, operationalize security, and they implement and also enforce security policies. And in doing so, they facilitate auditing, and then therefore they facilitate compliance. So it provides you a mechanism to show an auditor, this is how I am protecting my keys, and then that also then helps you comply. And as we mentioned in the presentation, HSMs kind of had their genesis in the banking industry, but now with more and more security regulations and those security regulations becoming more stringent, they're now being used across the industry, and they are considered, their use is considered a best practice amongst cybersecurity professionals. Let's see, you want to add anything else to that, Charlie?
No, I think you covered it really well.
Question here.
Yeah.
Okay, I see another question there. Is there a software security module available? Well, I mean, the term hardware security module kind of implies that it is hardware. I've seen different types of marketing around software security modules, but again, going back to my point that I made earlier, software security is soft security. That's what we like to say. You really have to ensure that a root of trust is anchored in a device that is certified, that it applies all these security controls that we talked about, and that it ensures that you're not going to be able to see where keys are, which is the real problem in terms of ensuring the security of applications. If you're encrypting information, if you are controlling access, you want to make sure that the keys and the credentials that you're using to control all of this reside in a trusted place, and that's where the root of trust comes into play.
Like you're saying, I mean, if a software emulator, if you will, is never going to reach the same level of FIPS and common criteria certification. It can't.
Mm-hmm. And we have one of our viewers had something interesting here. Anyone who attempts to generate random numbers by deterministic means is, of course, living in a state of sin. Young one, Newman.
Yeah.
So, yeah, great discussion. Don't see any other questions coming in. Anything else on your side? Charlie, anything else you wanted to add?
No, I think that quote's a good way to adjourn the presentation, really.
Okay. Well, we want to extend our thanks to HashiCorp, and we're very glad to have been here presenting and answering the questions. And with that, we'll close it here, and we'll thank our audience, and wish you have enjoy the rest of the Zero Trust Roadshow.
Roadshow.
Thank you.